Hello friends, welcome back to the bench. Thank you very much for joining me. Our patient is in Asus Vivobook. That is model, it says over here on the case somewhere, K6602V. Now, this is another patient that suffered a power surge. It's in fact from the same customer. And unfortunately, this one too has been sent to the butchers. This might be confusing, but if your laptop breaks, you send it to a technician, not to a butcher. I try my best not to criticize other shops, because this is hard work. It's not exactly, stuff goes wrong, and there's no point in belittling other shops. But in some cases, it just looks to me like this one is that you really just don't care. Or I don't know, if you because looks like this transistor was replaced, right? So obviously you operate with hot air. Transistors require a lot of hot air, a lot of temperature to release, because they dissipate that temperature relatively quickly. So doing that next to plastic components, a connector here, and a charging port here, it's just, what did you expect? That if you blow hot air, only this part is gonna get hot, but nothing around it? Now, was the cable at least removed? I don't see any signs of melting on the cable, so at least, alright, at least that's that. Let's see, does it lift still? It lifts. Maybe it works? Tough to say. But it is compromised. At this point, it is compromised. It should be replaced. The whole connector here. So added work. This is what? This is network. Again, it's compromised. Now it needs to be replaced. We have a nice solder blob over here. What for? I expect shaky hand or something, and the solder didn't go where it's supposed to go, but it's weird that it's all the way here, and this seems okay. Now, these are coils, and that's a diode that looks like a Zener diode, and we have a big solder blob over here. Should they be touching? Most likely. It's most likely from charging port. These two coils are entering this transistor. This one is probably controlled by BQ chip, if it's a BQ chip architecture. So the first one opens, the second one opens, and that's what delivers power to the rest of the laptop. Now, first transistor was replaced probably because it was shorted, right? This is actually after a power surge. It is understandable and even expected that this transistor will short out, right? So this one is no longer shorted, so good. Actually, I'm doing it in the wrong direction. It should be this direction, and it's showing pretty much the same in both directions. There should be a diode inside this transistor, so it's kind of weird that it's showing the same reading in both directions, but that's fine. So you replaced this transistor, and that relieved the short, but you connected power and it still doesn't work. Do you know why? Because second transistor is shorted. It's a piece of wire now. Well, it's showing 0.8, 0.6, that kind of stuff, but it is shorted. Oh, and now it's open line. Was it? Yeah, dead short. Dead short on the second transistor. That's why the computer didn't turn on after you replaced the first transistor and melted a whole bunch of stuff. But this computer can also work with USB-C. And when we connect USB-C, It negotiates the voltage and it charges fine. Well, for some reason it's not charging now, but it was charging before when it actually even booted. The fan started spinning. Let's try maybe other port. No, I think I checked on this port like a minute ago. I connected it and it started charging with 2.5 amps. Maybe this port. Yeah, so it's charging 3 amps from this port. Oh, and now it dropped, but it started pulling 3 amps for a second. So maybe it isn't actually charging, because that's what I tested, right? When I connected it, 1.75. So it is not charging. Less than 2 watts. Let's connect to the charging coil and see the voltage. 5 volts. The battery might be dead, and that's why we're seeing 5 volts. We have 3.3 on this one, or maybe, oh, hang on, maybe this is the charging coil transistor. We got 19 on it and 19 here. That's kind of unexpected. Why does it jump to 3 amps? And I would expect this coil over here to be a charging coil, but we have plain 0 on it. Let's see, battery voltage is 19. Is this what? We have 19 volts on the battery. Yeah, let's disconnect it, because this is 12 volt battery and there's 19 volts on the battery when we connect the charger. Now we have 4.2 volts on the battery. So looks like yeah, this is battery. That is so weird, because I honestly thought that it was charging from USB-C, because I just connected it for a second and I noticed like 2.5 amps. So I figured, okay, it's charging, so I removed the cable. But it looks like it jumps to 3 amps and it dies. But on the battery, so this resistor over here, that is not marked, so we have no markings on the board, which is just as well, because we don't have a board view for it. Let's see. So if we measure to ground from here, that's like megs, right? But now we want to measure to the input voltage. So something could be shorted, that it just sends 19 volts over here, which it shouldn't, because that goes directly to the battery, and on the battery we have 19 volts. On the battery that is a 12 volt battery. So obviously it's grabbing power through the from the charger, directly from the charger. And what happened here? What is that? Why do you guys keep doing this to me? What exact? And it's shorted between here and here. Should it be? Maybe, but it just doesn't look good in either case. A big solder blob. Yeah, not good. Then we have another something here. What was the purpose here? These are big transistors. I would say these two are controlling the coil. So there should be a BQ chip or some other charging chip. But we also have transistors here. Now so one of these could be shorted, and that's why we get 19. Because some of these, this one's fine, because some of these will allow charging from the discharging from the battery and charging the battery. Right. This one's fine, so no shorts here. No shorts here. Now I'm testing pretty much blindly for shorts because I don't have a board view. So we're just kind of guessing here. Now if the top transistor was shorted, that would result in 19 volts being sent to the battery, but both top and bottom transistor, or high and low transistor, seem fine. Okay, I don't see anything over here. What is this? Does that say intersil? Yeah, that's an ISL chip, right? Let's see. Is that an ISL? I think it is. Let's try cleaning it. So if it's an ISL architecture, I'm unfortunately a lot less familiar with this architecture. You can't really get... I applied to get the schematics and stuff for the ISL chip, because they are being used more often now. There you go, yeah. So that's our BQ chip equivalent. That's our charging chip. Unfortunately, you know, on BQ chip, I know where to probe to test the chip. I know how to diagnose how the chip operates, right? What the conditions are, which one is power good, which pin should be at what voltage, and that kind of stuff. On this one, we had the same one on the Dell M16R1, on which we're going to be replacing the board, and so that is unfortunate. But that's not even the worst part of it. All right. So prior repair, prior butchering, 19 volts on the battery, shorted input chip, input transistor. But worst part is this. So is it just the top layer, or is it 2 layers? It looks like 2 layers are gone. Yep, that's the layer number 3, or actually that is probably a bottom layer. Maybe it's just 3-layer board. But it looks like we have 2 layers missing here. 2 layers missing, even if I had a board view, which I don't. There's no way for me to figure this out. Because I only have, if any, I only have the top layer, right? But it would definitely help, especially if we also had schematics along with the board view. Let's check if this is even worth it. Because if the CPU or GPU are shorted, then this is definitely not worth even spending this much time on. The CPU V-core is at 30 ohms. 30 ohms. 135 ohms, so that's a memory coil. And this should be I/O. It's fine. So next, the GPU. Is the GPU core shorted? This looks like not very powerful GPU, so the resistance should be measurable with my device. 1.1. Well, that looks good to me. 1.2 over here and 1.1 over here. That looks good to me. I would say the GPU is not shorted, which is good. After power surge, it's possible. So let's test a few other coils. I know I had 5 volts. This coil is... I got 31 ohms on this coil. It's a little low, depending on what this coil does. But it seems a little low to me. No short though. On this one we have almost 3K, so this is good. So on our battery, there should be battery voltage, so we might be fooled over here. Yeah, it's showing, oh well, no. 100K. Yes, on the resistor. Well, this reading on the resistor is going to be fooled because there's battery voltage, which is very low, like 5 volts. So that's why the computer might not charge. Right? We have, oh no, we have 400 millivolts on the battery, which might be good because the battery might not turn on. Let's see if we have 3.3 on the battery. It should be yellow cable, yellow one, and we have 0.2, 200 millivolts. On the white, 200 millivolts, and this one is 0. So on this one, we should have 3.3. So the battery is completely discharged. But even if it is, there's no way the computer is going to start charging with 19 volts. In addition, we don't see much power going in, right? 1.7 watts, something like that. So it's definitely not charging, although it does start charging, which would be normal, right? You connect the charger, it starts pulling an amp, 2 amps, and it stops because the battery is completely discharged. So the ISL just cuts off the power. That would be normal, in which case we can just, charge the battery manually, ignoring the, ignoring the charging circuit, charge it directly with low current just to bring the voltage up. Once we bring the voltage up to like 11 volts, the ISL chip should start charging it. But that would be all good if we didn't have 19 volts on the battery. That should never happen. It's ridiculous. So, in light of this, if I get the board view, I might be able to do something with it. But it's there's no guarantee. There's like too much damage over here. But depending where it goes, maybe it just goes to the V core, and maybe just one trace is missing over here. But judging by the small resistors, small components over here, we have relatively big trace over here, right? We have big plane over here and vias that are now missing. And this was 1 via over here, 1, 2, 3 over here, and 4 vias over here. So this was probably going like this, and we have another trace over here and over here, and we're missing probably a coil. This was probably a coil. Maybe a big cap, could be as well. Probably not a cap. I mean, it could have been, because we have plenty of other caps over here. Now here we have another resistor, and this is our cap, which is, let's check the resistance on it, and if it's 31 ohms. So this looks like it's going to the CPU. Was the CPU at 31 ohms, V-core? Yeah. So this is V-core for the CPU, which, again, we're missing something here. Pretty much similar case to what we had last time from the same guy. It's like you really don't have luck when it comes to the technicians that work on your stuff. So this needs to be replaced. I mean, I think, because I don't know, it kind of, this part looks like it came from the factory. This one doesn't, but this one looks like it came from the factory unpopulated. So I might be wrong about this, but this is definitely V-core over here on the CPU V-core. So that's why the computer is not going to start, obviously. But the bottom layer is what concerns me. In addition, you see those 2 data lines that go here? Now, I said in my previous video that it is kind of against the code, the best practices, that you don't run tiny traces like that underneath the big power lines. But as I said, that it's not a guarantee. They do what they want to do. If they want to run data lines underneath the V-core, they can do so. It's gonna work, right? Maybe it'll be unstable, and in cases like this one, it's gonna be difficult to repair. But no, this is not great. But let's do a few other things so we can charge a bench fee, right? Is the phone... Oh, I forgot to charge it again, but it should be enough. Let's see a thermal footprint and see if we can spot anything suspicious once we connect the power. Because 19 volts on the battery, it means that we have most likely a short somewhere, right? And 19 volts is just shorted to the battery, all right? Which would explain why the laptop starts grabbing 3 amps, right? Because the battery is discharged and it's happy to accept 19 volts, no problem. And then the chip on the battery, there's also MOSFETs over there, are disabling charging because the input voltage is too high. So that would make sense. So let's see if we can spot anything on the camera. Yes, we can. Okay, so this chip, it's not like they are super hot. There's only 34 degrees on them. So that might indicate that they're just working. They're not faulty. Yeah, so one of them is the ISL. So the ISL chip turns on. Looks like 33 degrees. So not horrible, but not great either. So what is lighting up is the ISL chip. 33, 34 degrees. I'd say that's normal. I say this chip is working properly, meaning it's not shorted. If it's working properly, hard to say because the input transistor is shorted. The ISL chip should detect that and not allow the computer to turn on. However, when you connect to USB-C, oftentimes USB-C comes after those transistors, right? So it's fine. But then, if it's shorted to ground, which it is, it should still interfere. Maybe it's past another transistor, who knows. Without the board view, it's kind of guesswork. Especially if this was a BQ chip architecture, I would have a lot more information. With this one, and without the board view or schematics, there's a lot of guesswork. So this one is warming up, which seems fine, and this one, if that's an EC chip or Super IO, IT55, yes, IT55771 or IVG. IT557. It's definitely EC chip, and again, it doesn't look like it's. Oh no, hang on. It might still be shorted because the current delivered to the EC chip is highly limited. So the chip might light up looking like normal to like 30 degrees, but it's in fact shorted. But that would be accompanied by something else that stabilizes the voltage for the EC chip, and oftentimes it is somewhere very far from the EC chip. So without the board view, it's gonna be tough. But these are the only things that are lighting up here. Let's take a closer look at this. Yeah, what do you think? Is it? Yeah, it looks like 2 layers are gone to me. This is the second layer and this is the top layer. It looks to me like 2 layers are gone. Because typically boards don't look like this underneath the first layer. This is like complete internal of the board, and we can see traces on the other side. Plus, missing components here. So this was another resistor over here or a coil or something. 2 vias over here. going somewhere. I mean, this is not even, I don't know what the condition was after the surge over here, right? It could be that the other technician just scraped too much from here, and maybe only the top layer was damaged, not the middle layer, and accidentally middle layer was removed. But you can see here that it exploded, right? It made a big gush in the board. We have a hole here. So since we don't know, maybe that was necessary and it was no technician's fault. So I could live with this, right? But not with this. Not with this, by no means. It's horrible. Absolutely horrible. Because by doing this, you're introducing more issues, basically. All right. And how did you miss the second transistor being shorted? Or the second transistor wasn't shorted and you replaced the first transistor, and then after you plugged in the power, the second transistor shorted out. Could be. And then you just gave up on it. Could be. Okay, the board model is a K6602V revision 2.0, R2.0. If you guys have a board view for this, I could give it a try, or at least see why there would be 19 volts on the battery. So what can potentially be shorted to cause that. ISL chip seems okay. I would say EC looks fine, but again, with the board view, I can check how it is powered and see what is stabilizing or regulating the voltage applied to the EC chip, and that way I could confirm that it's not shorted. We could route the V-core through here, because right now the V-core is not going to be present because there's no physical connection, which is fine. So the first time I turned it on, first time I connected the power, I had a fan spin, and I don't see the fan spin anymore. Yeah, 3 amps, and it drops to 0. But I had a fan spin before. See if we, where's the power button? Yeah, there's no reaction from the power button, to be expected. I mean, not really. I would perhaps expect a little bit of something if the EC chip is actually working, because the fact that the EC chip lights up under on the thermal image doesn't mean that the chip is actually functioning properly, right? It indicates that the chip has turned on and it's doing something perhaps, but all it actually confirms is that there is current flowing through the chip. So it could be shorted chip with just current limiting, or the power side of the chip it's consuming power, but the chip itself is not working. Perhaps corrupted data inside the chip, could be, or some other fault on the chip which is not power related, also could be. After power surge, anything is possible, even the holes in the motherboard. All right, I'm gonna see if I can locate the motherboard, the board view. I mean, I already checked, I can't. We don't have the original charger, and unfortunately this is the one that uses those tiny chargers, tiny Dell chargers. So I don't have this one. I only have those big ones. So I can't really check it from the regular power adapter, but we do have shorted transistor, so I know it's not gonna work, so I don't even have to check, but it should charge and it should work from USB-C, at least this one. Not every computer will charge from USB-C. Some just require the charging port, and USB-C is only for peripherals and stuff, but it will not charge. Not this one though, this one does. All right, I'm gonna put it back together, and unless I get the board view, there is nothing I can do, like zero, absolute zero. With the board view, all I can do is just try to figure it out, but the probability of getting this one fixed is slim to none because of this huge damage to the board. I know. So that's all we can do at the moment. I'm gonna put it back together, and we'll see if I can get the board. Then we're sending it back with this analysis. I mean, we can replace the motherboard. We can probably find it. This shouldn't be a very expensive motherboard, and we can get the computer working again that way. But at the moment, that's the only way we can get it to work. There's no way I can fix this without the board view. Alrighty, hope you guys enjoyed this struggle. Thank you very much for watching. I do appreciate you, and I shall see you guys in the next one.